Let's find the derivative of functions by using power rule of derivative. We have a function y equal to x to power 7 and we have to find its derivative. First of all, the derivative notation would be y dash, or it's dy by dx because y depends upon x. Then we will apply the power rule of derivative on x to power 7. Power comes on side x and you subtract 1 from the power, which gives you 7x to power 6. Let's attempt another question. You have y is equal to 2x to power 5. So to find the solution, you find y dash, you keep 2 on the side, apply power rule on x to power 5. 5 comes on the side, x to power 5 minus 1. You simplify 2 into 5, x to power 4 gives you 10 x to power 4. Let's attempt another question. You have y equal to x to power minus 2. So to find the derivative, you find y dash. You can again apply the power rule. It doesn't matter the power is a negative number. So you bring the power on the side by the power rule of derivative x and you subtract 1 from the power. And then you simplify. It gives you minus 2x to power minus 3. And then you can simplify it further by putting minus 2 divided by x to power 3. So when you bring this x to power minus 3 down, it becomes x to power 3. Let's solve this question that you have an expression y is equal to 1 over x to power minus 20. Now we know that if the expression y is given in the form something by something, like in the fractional expression, we can apply the quotient rule. But in this case, we don't need to apply the quotient rule. We can just rewrite it in a simplified way and then can apply the power rule. How so? So bring this x to power minus 20 up and then simply apply the power rule, which is 20 x to power 20 minus 1 gives you y dash equal to 20 x to power 90. Let's attempt one more question. You have to find the derivative of an expression y is equal to 2 over x to power 7. Since this is a fractional expression, we can apply the quotient rule, but we can avoid that. We can simply rewrite this expression as 2 into x to power minus 7. And now we can apply the power rule. So we will keep 2 on the side and then apply the power rule on x to power minus 7. What does it do? Minus 7 comes on the side, x to power, and subtract 1 from the power, which gives you 2 into minus 7 into x to power minus 8, which gives you minus 14. And then we can bring x to power minus 8 down by writing it as x to power 8. Let's look at this question. You have to find the derivative of the function y, and the function is described as minus x to power 12. Now to find the derivative, you keep minus as it is, or it is minus 1, and then apply the power rule on x to power 12. It gives you 12 x to power 12 minus 1, which gives you minus 12 x to power 11. Let's look at this question. You have to find the derivative of this expression 2x to power 6 plus x to power minus 9. So to find the derivative of y, we will first write y dash, which is derivative of y with respect to x, because y is depending upon x on the right hand side. And then you find the derivative of the first term and the derivative of the second term. In between you will have the plus sign. So for the derivative of the first term, you will keep 2 on the side and then on x to power 6 you will apply the power rule, which is 6 x to power 6 minus 1 plus power rule on x to power minus 9. So minus 9 comes on the side, x minus 9 minus 1, and then you can simplify this whole expression. 6 to the 12, x to power 5 minus 9 x to power minus 10. You can rewrite this expression in a more simplified form. 12x to power 5 minus 9 over x to power 10. Let's find the derivative of this expression. Y is equal to 1 minus 2 square root x. So derivative of y is denoted as y dash. Now derivative of 1, which is a constant, is 0 minus 2 on the side, and this can be written as x to power 1 by 2. So apply the power rule on x to power 1 by 2, which gives you 1 over 2 on the side, x, subtract 1 from the power. Simplifying it gives us minus 2 into 1 by 2 into 1 by 2 minus 1 on the power becomes minus 1 by 2. This 2 cancels with this 2. So you have y dash as minus x to power minus 1 by 2. Or it could also be written as minus 1 over x to power 1 by 2. So bring this x to power minus 1 by 2 down by making the sign as positive, which can be written as minus 1 over square root x. Let's find the derivative of the expression x cube minus 6x square plus 3x plus 1. So the derivative of y is denoted as y dash by the power rule. 3x square minus 6 into 2, which is 12x plus 3. Because the derivative of x is 1 and derivative of 1, which is a constant, is 0. So that's the first derivative. Let's say you are asked to find the derivative of this expression again. So it would be the double derivative, which could be, again apply the power rule on the first term, keeping 3 on the side, and the derivative of x square is 2x minus 12x derivative is 12, because 12 is the constant on the side and derivative of x is 1, plus derivative of 3, which is a constant, is 0. So the double derivative here is 6x minus 12. You can find the derivative of this expression again, which would be the third derivative. So derivative of 6x is 6, because 6 is on the side and derivative of x is 1. So here you have 6 minus derivative of 12 is 0, because it is a constant. So you have y triple derivative is 6. This is how you can continue to find the higher order derivatives. Let's find the derivative of the expression 1 over a x square plus 1 over b x plus c. Derivative is denoted as y dash. Now 1 over a is constant, so we will keep it on the side. Derivative of x square is 2x by the power rule, plus 1 over b is constant on the side, and the derivative of x is 1 by the power rule, plus derivative of c, which is a constant, is 0. We will simplify this expression. 1 over a, 2x plus 1 over b, that's it, and we will close the bracket. Let's find the derivative of this expression. Y equal to 7x to power minus 6 minus 5 square root x. Before we find the derivative, we can rewrite this expression as y is equal to 7x to power minus 6 minus 5x to power 1 by 2, because square root means the power is 1 by 2. And now apply the power rule of derivative on all terms. 7 is the constant on the side, and apply the power rule of derivative on x to power minus 6. It gives you minus 6 x to power minus 6 minus 1 minus 5. Power rule of derivative on x to power 1 by 2. It gives you 1 over 2 x to power 1 over 2 minus 1. And you have y dash as 7 into 6 minus 42 x to power minus 7 minus 5 by 2 x to power minus 1 by 2. And then we can simplify this. Y dash minus 42 over x to power 7 minus 5 by 2 into 1 over square root x. So this is how we apply the power rule of derivative on an expression. We can attempt one more question, which is find the derivative of an expression y is equal to x to power 3 by 2 plus 2 whole divided by x. Now we can see that this expression is in the form of fraction, something by something. So we might try to find the derivative of this function y by using the quotient rule of derivative, but we can rewrite this expression and then maybe we can avoid the quotient rule. We can write it as y is equal to x to power 3 by 2 divided by x. We can break apart this expression 2 over x. And then we can write it as x to power 3 by 2 minus 1, because here the power on x is 1, and when it goes up it becomes x to power minus 1. So we can write this expression as x to power 3 by 2 multiplied by x to power minus 1 plus 2 into x to power minus 1. And now we can find the derivative, which is 1 over 2 x to power 1 over 2 minus 1 plus 2 into minus 1 x to power minus 1 minus 1. We can simplify this expression, which gives us 1 over 2 x to power minus 1 over 2 minus 2 x to power minus 2, which gives us 1 over 2 x to power 1 by 2 minus 2 over x square. So we bring x to power minus 2 down, it becomes x square. We have y dash is equal to 1 over 2 square root x minus 2 over x square. So this is how we attempt the power rule of derivative. So in the next video lectures, you will see that we will find the derivative of the functions by applying the product rule and the quotient rule.